So let's start our AHP analysis. So this is a comparison matrix which I made. So in comparison matrix, I'm comparing all layers with each other. So in general, I have 15 comparisons. If you remember from the tutorial, the number of comparisons is calculated due to this formula. So I have 6 layers, and in general, I will have 15 comparisons. So the scaling rank which I used is from 1 to 9, only odd numbers without even numbers. So but you can change the other scale ranking. It's up to you. For instance, you can change from 1 to 10 using all numbers, all digits. I decided to use this odd numbers from 1 to 9 in order to facilitate my work. I just get used to work with such kind of numeric values. So let's just have a brief look to the comparison of layers. So it's up to you which ranking and values you will assign when comparing two layers with each other when creating comparison matrix. It depends on your expertise, it depends on your knowledge, also it might depend on your study area. Also, you can do a literature review and try to understand, try to find the value that other authors assigned for different layers. So, and also it depends just on logic and consistency. For instance, when comparing land use, land cover, and slope, I assigned to slope 3. So it depends. It says that I prefer slope layer and slope factor more than land use and land cover 3 times, because I think that slope more influence to creation of groundwater zones rather than land use and land cover. The areas which is in downslope areas, which has on the low altitude areas, mostly accrue both soil and deposited soil and water, and therefore they prone to create groundwater zones. The same concerns depression. Comparing to land use and land cover, I prefer depression more because depression is something close to slope, so it shows the difference between a flat terrain with just terrain that has not flat sharp regions such as concave and convex areas. So these areas also might have prone to create groundwater because the concave areas prone to accumulate water. So when comparing land use and land cover, I significantly prefer alignments comparing to land use and land cover, because alignments are areas where tectonic plates interact, and these areas are, according to geologists and hydrogeologists, are almost always have some groundwater zones. So alignments are on the forefront when we talk about groundwater potential mapping. So precipitation and land use and land cover, I slightly prefer precipitation than land use and land cover, despite that my precipitation doesn't significantly differ within areas. If you have precipitation, I slightly prefer more than land use and land cover, but you can assign the equal values to both of them. So when it comparing land use and land cover and SAVI, I think that SAVI important more than land use and land cover, because according to our just classification of our study area, we divided our study area into different soil types, and certain soil types have high potential to create groundwater zones. For instance, sandy areas, because sand has larger pores between sand parent material has larger pores comparing to clay or silt, and it's easy for water to penetrate through soils, sandy soil or sandy loam. So depression and slope have equal ranking system. You should be consistent when ranking, when comparing different layers. For instance, if you might see here, when comparing land use and cover with slope and depression, I prefer slope and depression layers on the same extent. Therefore, I need to assign the equal ranking when comparing slope and depression. Otherwise, the consistency index and consistency index and consistency ratio will be higher than 10%. So the alignment, comparing alignments and slope, I obviously prefer alignments more than slope, but not at the same extent as comparing to land use and cover. I think that slope also have significant influence to groundwater. Comparing slope and precipitation, I think that slope slightly more important than precipitation. But if you have in your area different precipitation classes which significantly differ from each other, then I think that you might prefer precipitation more than other layers or at the same extent, because precipitation also has a significant influence. So slope and SAVI, I think that they both equal. Well, SAVI influence to different soil types, and slope influence to deposition and accumulation of water. So alignments and depression, I slightly prefer alignments more than depression, but see that I am slightly inconsistent in this case, because when comparing slope and depression, I assign them equal, but here I'm slightly inconsistent in my answer, because when comparing slope and alignments, I assigned 5, but when comparing depression and alignments, I assigned 3. I think the reason is that I think if I will assign 5 in this case, alignments will have the major and probably the most important impact to creation of groundwater, and ArcMap during the weighted overlay only assign higher values with areas with high alignments. And in order to decrease the importance of alignments and increase the importance of other factors such as digital elevation model, from which we derive both slope and depression, I assigned it less value to alignments comparing to slope, when comparing with slope layer. So depression, precipitation, depression is higher, etc, etc, etc. So I will upload this Excel file here to the course, and you can assign your own values and create your own comparison metrics. The next step will be to just, as you might remember, when we assigned values, to create reciprocal matrix. When we compared all values, all layers, the next step is to create reciprocal matrix.